In the zone, the relative efficacy of antiseptics and disinfectants. In this PowerPoint, I will start with a brief overview of the experiment, then focus on the results and discussion section of the experiment. The purpose of this experiment was to test how effective 6 antibacterial agents were against various bacterial strains in relation to each other. Okay, for an introduction, first, our hypothesis was that all of the antiseptic and disinfectant agents that we used would be effective against all of the bacterial strains. So as you can see, there were 6 bacterial strains: E. coli, S. aureus, P. aeruginosa, P. vulgaris, B. cereus, and E. facillus. Then we tested 2 disinfectants, Clorox bleach and spick and span, as well as 4 antiseptics: hand sanitizer, hydrogen peroxide, mouthwash, and rubbing alcohol. The difference between a disinfectant and an antiseptic is that an antiseptic is applied to living tissues, while disinfectants are recommended for use on inanimate objects such as surfaces or equipment. Here is a visual of how we set up the petri dishes and the plates for experimentation. There was, where the green is, that is where the bacteria was seated. Each bacteria, each different type of bacteria got 2 plates with each including and totaling the 6 different types of antibacterial agents. After a week of having the seeded bacteria develop into colonies, we measured the zone of inhibition, as this picture from the biology department direction shows. And this width of the zone of inhibition is how we measured the efficacy of each antiseptic and disinfectant. These orange circles represent where the colony would be. As for the results, right away you can see that mouthwash and rubbing alcohol had 0s across the board for their zone of inhibition. You can also see that hydrogen peroxide was quite the opposite and had much larger zones of inhibition. 10% bleach, spick and span, and hand sanitizer were less clear and had more varied results. In this graph of results, the chart clearly shows that hydrogen peroxide's effects were much greater than any of the other antiseptics or disinfectants tested. It also shows that spick and span were effective against about half of the bacterial strains, while 10% bleach was also effective against about half. And hand sanitizer, surprisingly, was only effective against 1. And mouthwash and rubbing alcohol, as it showed in the chart, or in the table, that there is no efficacy, as far as a zone of inhibition goes. So here's a table of the average zones of inhibition. You can see that, as the chart showed, hydrogen peroxide is the highest. Next is hand sanitizer. 10% bleach follows, or spick and span follows, and 10% bleach is less than that. Hand sanitizer has the second highest average, as you can see, but this may be deceiving because it really only blocked against one bacterial strain. So to make the numbers reflect the consistency as well as the size of the zone of inhibition, I put a consistency coefficient and multiplied it by the average zone of inhibition. So when I did that, the numbers came out to be more reflective of the consistency along with the total the measurement of the zone of inhibition. And it has hand sanitizer falling after bleach and spick and span. The coefficient is the number of bacterial strains that the agent was effective against divided by the total bacterial strains, and it is the fraction of that. Okay, well, since the hypothesis originally was that all of these antiseptics and disinfectants would be effective against all of the strains of bacteria, because they're made to be effective against bacteria. I mean, it clearly didn't happen that way. Perhaps this is because mouthwash is designed to fight oral bacteria, and most of these bacterial strains are more general and not typical to be found in the mouth. Also, while like Scope and Germex here, they are made to be safe for like everyday use on human tissue, and they may be less potent for that reason. While realistically, say hydrogen peroxide, which is for use like in sterilizing cuts and would probably be used less often, and only for cuts, so it would probably be more potent. Also, these three low measuring zone of inhibition agents all use alcohol as their main ingredient, which may question how effective that is. And that brings us to the question, is hand sanitizer truly effective? And to find this out, I did some research, and according to Science News, alcohol-based hand gels are less effective than washing hands with plain water. Also, hand sanitizer was found to be effective against viruses in 30 seconds, but it was highly variable. And this was found in infection control and hospital epidemiology. So, although hand sanitizer is very commonly used and is effective and found to be effective against a lot of bacteria. Its success with viruses isn't quite as good, and actual hand washing can be better. So like in conclusion, on live tissues and surfaces, washing and rinsing seems to be the best option, but since stronger sanitization agents with higher zones of inhibition are not safe to use on skin, but hand washing just with water sometimes can be even more effective than an antibacterial agent. Also, hydrogen peroxide seems to be the most widely effective agent tested and is also able to be used on live tissue. So that may be the best one to go with. Also, with the 3 alcohol-based antiseptics, the results of their ineffectiveness may imply that alcohol is only effective on more direct contact and does not create a zone of inhibition at all. Okay, and I would like to acknowledge my lab group, Kelly, Eric, and Dan, as well as our lab instructor, Dr. Dolly, and our TA, Chris Freimer, as well as the Ursinus College Biology Department. And here are the sources that I consulted in finding images as well as researching. Thank you.